This lesson is about forces in springs, and by the end of this lesson you should be able to explain Hooke's law and know the difference between elastic and inelastic deformation. The first task is to draw this graph. Now this is data that you may have been able to have collected yourself when you did the experiment of hanging a spring and putting on different forces, different weights onto the spring. And each time you did that you would have measured the extension. So these are the results that you would have got from an experiment like that. So hopefully you would have got a graph that looks something along these lines. And this is basically elastic material that is obeying Hooke's law. So Hooke's law is when the extension is directly proportional to the force applied. Now this applies to extension as well as compression. And so what that basically means is if you had a spring and you applied a force to it, it would stretch. But when you remove that force, it would go back to its original length. And this continues to be directly proportional until the spring has passed its elastic potential, at which point it will then deform. So it will be inelastic deformation. And that basically means the spring will no longer return to its normal length. And if we were to plot that on a graph, it would look something like this. And we can see that as it goes up, the spring no longer obeys Hooke's law, and that is the point of inelastic deformation. So the extent to which a spring will stretch is called the spring constant. And a spring that has a really high spring constant will not stretch as far with the same force as a spring that has a lower spring constant. And we can use this equation in order to work out the spring constant or the extension of a spring should we know the spring constant. So pause the video now and copy down this equation. So the best way to learn to use these equations is just to keep practicing. So have a little go at these three questions and I'll come back and show you the answers. So in the first question, it was just a straightforward case of picking out the spring constant and the extension and then plugging them into the equation. Force equals 5 times 3, which is 15 newtons. In the second question, they've asked you to find out what compression was. And so using your triangle, you should be able to rearrange the equation to make extension equals force divided by spring constant. And in this case, the extension would be 0.25 meters. And finally, in the last one was to rearrange the equation again to get the spring constant, which would give you the spring constant again is the force divided by the extension, and that would get you 8 newtons per meter. So hopefully you now have an idea of Hooke's law and you know the difference between an elastic and an inelastic deformation, and you should be able to calculate the spring constant using the Hooke equation.